All right, so these are the notes for circuits, and we'll fill in these blanks on our page. So first of all, there's a lot of blanks here on this first screen, so start filling in those blanks on your page. What is a circuit is what we're just defining here. So a circuit is a path where electrons or electricity can flow from a source of electric current. The source of electrical current is usually a battery, but it can also be a plug too. So it can be a battery or it can be a plug-in. And then current, what is current? Current is the rate of flow of electrons through a conductor. So that's what we measured on the little amp meter. And we looked, excuse me, at the speed of the electricity passing through. What's up? Give you time to fill in your blanks here. Huh? The cruise note.
Is it right after?
We good on the slide?
No.
All right, I'm moving on. All right, so there are two main types of circuits. When you guys were with me at the kidney table and we were doing the small groups, we spent a lot of time talking about the two different types of circuits and how they're different from each other and how voltage, current, and resistance were related to each other. So series and parallel are the two main types of circuit. Let's talk a little bit first about the series circuit, okay? So a series circuit, that is that circuit that just has one pathway. It's like a one-way road. So it provides only one pathway in which electrons or electricity can flow. When you have a series circuit, if there's a break, or in other words, if the circuit opens up, like we have a missing light bulb or we disconnect a wire, a break anywhere in the series circuit will cause the current to stop flowing completely. And if you remember, when we unscrewed one light bulb, the other light bulbs went out and the current went down to 0 on the ammeter. And then this last point on the screen says when resistance increases, so that means I add more light bulbs, current decreases. It means it slows down. So we saw this happen when we did the circuits back at the kidney table. When I started adding more light bulbs, the current decreased, it got slower. Examples in real life of series circuits are Christmas lights. Because think, if you have those Christmas lights and like all of a sudden the whole string just goes dead, probably because just one of the bulbs of that like 50 light string broke or isn't working or wasn't pushed in all the way, like the whole string goes dead, and it's extremely frustrating if you ask me. Circuit breakers in your house are also an example of series circuits. How many of you guys know what a circuit breaker is in your house? Anybody know what a circuit breaker is? So a circuit breaker in your house is just a protective feature that shuts off like a whole room or a whole area in your house electricity if it feels that the current is getting too hot. When the electricity is traveling through really fast and the current gets hot, it can cause what we call an electrical fire, which usually happens inside the walls of your house. It's really dangerous. So a circuit breaker just knocks out the whole circuit. Since it's a series circuit, it just cuts off power to the whole circuit, and then you usually have to go to the circuit breaker and reset it, but it'll keep knocking out if it gets too hot. And so that should signal to you like, maybe I have too many things plugged in. Maybe I'm putting too much stuff on this circuit. Like this happens a lot of times to people that like put up way too many Christmas lights and try to plug them all in the same outlet, and they got like 8 plugs all in these multi-prong plug things because they're trying to deck out their lights. This has happened to me before. I tried to win the neighborhood Christmas light decoration contest. I second place.
Oh, surprise!
I was in second. A sign in my yard that said like spectacular Christmas display.
What the?
That's it.
Hey, just wait till you grow up and you have your own house. Gotta have that sign in your yard. All right, parallel circuits. Parallel circuits, they provide multiple pathways for electrons or electricity to flow. So remember when we built the parallel circuit, we said there has to be at least 2 lights because there has to be 2 pathways. A break anywhere in the circuit, like unscrewing a light bulb or moving one piece or disconnecting one wire, does not stop the flow of electricity. That circuit can still work in the places that are still together. So remember, we had the parallel circuit at the kidney table. We had 3 lights and we unscrewed one of the lights. Well, the other 2 stayed lit and the current kept flowing. All we did was just break open one of the pathways. The rest of the pathways were still working. One thing that we noticed, this last point, is when resistance increases, so we start adding more light bulbs to a parallel circuit, the current also increased. This was the opposite of series. So in series, more light bulbs means slower current. In parallel, more light bulbs means faster current because we're opening up more pathways. Remember, I made the analogy to the lunch lines. The more lunch lines that are open, the faster you're going to get through the lunch cafeteria because you only pick one lunch line to go through and you're able to spread out more. Examples of parallel circuits in real life include things like the street lights. You guys ever notice that like one street light can be out but the rest of them are still on? Even your house is wired with parallels because think about it, like you can turn off the lights in your room but keep the TV on, or your phone can still be charging. So part of like in this room, this classroom right now, we turn off all the lights, but the projector's still working. So different things can be off and other things can be on at the same time. So that's usually like in our house. And even in a car, like the different lights inside the car, maybe one headlight goes out but the other one can still work, one blinker is not working. So a lot of things are wired in parallel. Another example that you probably read about when you were doing your drawing was a refrigerator. Think about your refrigerator. When the light bulb burns out in your refrigerator, does the whole refrigerator stop working? Yeah, it does. No, it's still keeping the food cold, right? Just because the light goes out doesn't mean that the whole refrigerator turned off. So if your refrigerator was a series circuit, if the light turned off, then the whole refrigerator would die and all your food would go rotting. But in a parallel circuit, even if the light bulb stops working, the other parts of the refrigerator that make it cold can still keep working, okay? This is just a picture of the 2 types of circuits. The reason I'm stopping here for a second is because when you take your quiz today, there's going to be lots of questions where it just shows you a picture and says, is this a series or a parallel circuit? Now, on the series side, the top picture is just a regular drawing. You can see the battery, the wires, and the light bulbs. The bottom drawing you also have to be familiar with. This is what we call the technical diagram. It's a diagram of a circuit. So the little 2 lines thing, like the darker, shorter line, and then the less dark, longer line, that indicates a battery. That's the symbol for a battery. And then on the bottom, where you see the circles with the X's in them, those indicate resistors, or in this case, light bulbs. So series circuit, there's just one pathway. It comes out the battery on the negative side, comes back through, okay? On the parallel, same thing. You see the drawing and then the technical diagram next to it. They represent the same thing, okay? So on your quiz today and on the e-cart that you'll take in a couple weeks, you'll see pictures of circuits and we'll ask you, is it series or parallel? So you have to ask yourself, is it series? Is it just one pathway? Or is it parallel? Are there 2 or more pathways? Okay. Let's talk about what those resistors are. So really anything in a circuit can be a resistor. A resistor is any object that does not allow the smooth flow of electricity through it. Any object that does not allow the smooth flow of electricity through it. So all materials can be a resistor. When we say electrons are just the particles that make up electricity. If we were to try to break down like what is electricity, it's these little teeny invisible particles called electrons that are part of the atom. So that's why you see us use both terms. So all materials can be resistance. Just think of like, what does it mean to resist arrest? If an officer tries to put you under arrest and you resist, are you going peacefully along with that officer? No, you're like fighting against them. You're not trying to. So think about how many of you guys have ever had to like run before? Like you run the pacer in PE or you run a mile or whatever. Now imagine if you had to start running, but you were running through waist-deep water. Like you're at the beach, or you're in a shallow pool, or you're in Puerto Rico where it's flooded, and you're trying to run through water that like comes up to your waist. Are you going to be able to run as fast if you're in a whole bunch of water? No. Okay, we can run through air a lot quicker. There's less resistance. Water would be like resistance. So just think that some materials make the electricity slow down. They can't travel through it as fast. Good metal conductors like copper have very little resistance, but there's other types of things that electricity can still pass through, but it goes through it slower because the material actually slows it down. Now, certain resistors are called loads, and a load is just a resistor that actually turns electricity into something else. So when we were doing our circuits, the batteries, let me try this again. When we were doing our circuits, the light bulbs were considered the load. It's a resistor, but it's turning the electricity into a different type of energy. Who can tell me what type of energy it was turning the electricity into? Light, which is what type of Mr. Cent energy? Radiant, right? So it was turning electricity into radiant energy. So a load is just a resistor that actually turns electricity into something else. Okay. One of the last things we talked about at the kidney table, was the voltage thing, adding more batteries. And we came up with the conclusion that no matter what, when I increase the voltage or add more batteries, that the current always goes up. It always increases. Remember, voltage is like force. It's the force that's pushing the electricity through the circuit. So the higher the force, the higher the voltage, the faster the electrons are going to go. Just like a car with higher horsepowers is going to be able to drive quicker than a car with lower horsepowers, okay? Or an athlete with stronger muscles could probably run faster than an athlete who's not well trained and doesn't have strong muscles. Then I want to leave with this last image here. I know we filled in the blanks, but I want you to look at this because this kind of helps explain the difference between a series and a parallel circuit with those resistors changing the current. So the first picture, a single resistor, these are cars on a toll road. Have you ever been in a car that has to stop and pay a toll before?
Yeah.
Now, imagine if you're on a big highway like Dulles Toll Road and they only have one toll booth. And every car, there's like 3 or 4 lanes of traffic, and they all have to funnel together into one lane and stop and pay 75-cent toll. That's going to slow down traffic. That's like a series circuit. All the electricity has to funnel through and light up that one resistor. But imagine if we started adding more resistors. So imagine if you were on the toll road and not only was there just one lane to pay the toll, but they also said you had to pay 75 cents, but 1 quarter at a time. So you drive up, you stop, you pay your quarter. Then you drive up a little further and you stop and you pay another quarter. Then you drive up like 10 more feet and you have to stop and pay another quarter. That's going to slow you even more down because you have to keep going and stopping, going and stopping, going and stopping. That's what happens when you add more resistors to a series circuit. As the electricity gets there, then it has to stop and do work. Then it keeps moving, then it has to stop and light up another bulb. Then it keeps moving, and then it has to stop and light up another bulb, all before it gets back to the battery and kind of gets recharged. Now in a parallel circuit, the last one, the more toll booths that are open, they're placed kind of in parallel or side by side. Well, that's going to actually speed up traffic because do you go through all the toll booths when you go to a toll plaza? No, you pick one. And usually you pick the one that has the least amount of cars in line, right? So when there's 3 toll booths open, it's going to speed up the traffic because now the cars can spread out to 3. And if there were 5 or there were 6 or there were 7, the more toll booths we put on there, the faster you're going to get through that toll because you can spread out, stop at one, and then keep going. So that shows us kind of a difference between series and parallel circuits with adding resistance. All right, so we are done with that. Now you guys are going to be doing the practice, and you're probably going to need your notes to answer the practice that Miss Murphy handed out.